In this screencast, we're going to talk about toxins that get into water. And I think, when people think about environmental science, this is one of the things that definitely comes to mind. Clearly, after all we've studied this year, you realize now that that's not everything that is involved in environmental science, but it's certainly one of the more public ones and one of the ones that brings the public's attention to the problems that the environment faces. So let's just talk about it. Okay. So of all the things that cause problems as far as water pollution, one of the ones that is of large concern is oil spills. And so before we talk about that, we just need to learn a little bit about what crude oil is. We're going to study it in our next unit quite a bit because it's one of the main ways that we provide energy to our society. But in short, here's what we can tell you. What I'll say right now is that crude oil is this mixture of carbon chains and carbon rings that have hydrogen attached to them. We call these hydrocarbons. So they're like carbohydrates minus the oxygen. Okay. So instead of C6H12O6, it might just be C6H what 14. Okay. So anyway, basically these are formed when plankton in ancient oceans millions of years ago absorbed light energy, turned into sugars and starches, died and fell to the bottom, got buried under mud. Over time, more and more mud and sand piled up on top of them. They got heated up, they got compressed, and basically that the oxygen got sort of baked off, and the sugars and starches got turned into these carbon chain compounds. But it's this whole slew of them, right? So there's these chains, there's rings. Some of them might be as short as a single carbon or 3 or 4 carbons. Some of them might be 100 carbons. So it's just this mixture of carbon chains and rings with hydrogen on them, hydrocarbons, that we call crude oil. Now, the thing about crude oil is it needs to be separated into different components in order to be usable as mostly for fuels, but also for solvents and things like that. And so the way that we separate it into, say, like gasoline, petrol, diesel, jet fuel, kerosene, is we use a process called fractional distillation, which basically means you heat it to different temperatures, and the smaller the lower the atomic mass is, the more likely it is to volatilize and then get pumped out. And so they use there's these things called oil refineries that take the crude oil and refine it into these different products using this process of fractional distillation. But you have to get it there to do that. And that is really the weak link in the chain, other than the fact that it causes global warming. But the oil spills happen when we're trying to get it from its source to the refinery. And that's usually where it happens. And so basically what you've got is ships can wreck. The oil wells themselves can have problems and release oil into the water, or we can have problems with the pipelines that move it across land. And in all these cases, we get crude oil that gets into either marine water or groundwater, and where it causes a lot of problems. And we're just going to articulate what those problems are now. Okay, so the first thing we have is, and usually when we think of oil, the bigger economic calamities have happened are with oceanic oil spills, and here's what the problem is: oil is made out of carbon chains, and they're nonpolar. So if you look at the bonds between carbon and carbon or carbon and hydrogen, these are nonpolar bonds, and water is hydrogen and oxygen, and it is polar bonds. So water molecules stick to each other, and they don't stick to oil. So the oil does not dissolve into water. It doesn't dilute itself. It stays clumped together, and it's less dense than water, so it tends to float to the surface. So we've got this, just like if you took like a salad dressing that's made out of oil and vinegar. Vinegar is basically water with some acid in it, and the oil floats on top. Is the exact same idea. And so you get this thing called an oil slick that can spread out for many square kilometers. Okay, now there's a host of problems. Okay, let's just start with the fact that these compounds are toxic. They are known carcinogens. They are mutagens. They have all these problems associated with them. But let's just start with one of the more public ones, one of the ones that gets people to really respond viscerally and emotionally to this. And that is, we see animals that get coated with oil. And why is that so bad? Well, many marine animals, be they mammals like seals or otters or birds, they often have to insulate themselves from the water, right? And if you were to jump in the ocean, you'd quickly die of hypothermia. Well, why don't these animals? It's because they have a protective layer of air, and the way they maintain that is their fur or feathers are able to repel water by having oils on them, naturally occurring oils. Like your hair has oils in it, right? But like dissolves like. So what happens is the oil in the water, when you have an oil spill in the water, it mixes with the oil in their bodies and they lose their insulative properties and they end up dying of hypothermia. So that's one of the biggest loss of life to marine animals immediately following an oil spill is usually that. Now, it tends to do a lot of other things too. Okay, so cetaceans, things that breathe through holes in their heads, like whales and uh, um, dolphins, that hole can get filled up. They come to the surface, they feel they've got to the top of the water, and now they're getting oil in there, and they can't get it out, and so they suffocate. Clearly, it can kill clams and other larval organisms. It keeps them from accessing oxygen. And as I said, it's toxic, so it can get into the food chain. As it gets in the food chain, it tends to work its way up the food chain, causing more and more problems as it goes. And then when it washes ashore, it gets onto beaches and makes them absolutely unsightly. And if there's clams here, well, you can't harvest those clams anymore. People don't want to go to this beach because it stinks and it's gross, and who wants to lie on toxic waste? The other thing is it tends to get into estuaries. So we're talking about like salt marshes and mangroves, which are really important areas for juvenile fish to, it's where juvenile fish live. And so it gets in there and it just doesn't come out. And now you've got the fish don't have any place to go when they're after their spawn. So it's just makes a mess of everything. It's terrible. And it's very visible. The news cameras come out and film. And that's the thing. It's like there's a lot of environmental problems that most people don't pay attention to because the news cameras don't come out. When this happens, the news cameras come out and people get upset. Now, how do you mitigate these when they happen? Well, the first thing you do is you try to make them not happen. You try to insist that ships have certain rules they have to follow to make sure that, like in the state of Washington, when a ship comes into the inner, close to land, it has to have multiple tugboats to keep it from drifting onto rocks and so on. But let's just say we didn't prevent it from happening, and now the oil's in the water. Okay, so one thing we can do is you can have what are called booms. Booms are these inflatable barriers, and because it floats on the top of the water, as long as it's not too much wave action, I can basically scoop it up and then bring in some sort of a pump to slurp it off the top of the water. So that's one way. Sometimes they just burn it. If it's got a lot of very volatile fractions in it, so very what we call light crude oil, and this hasn't had too much emulsification in the water, you can just burn it. Sometimes they put like these absorbent materials on top of it that soaks it up. Different types of plant fibers, whatever. It will soak in the oil, and they can just gather that up. Sometimes what they do is they actually put a chemical on it. It's called a chemical dispersant. This is a little bit controversial, but it definitely solves the immediate problem. So you put this chemical on it, and basically it causes the oil to clump and sink to the bottom. Now, when it's on the bottom, it's still a problem, but a lot of those problems are A, not really visible to us, and B, less damaging overall than it would be to, say, destroy a mangrove forest or a wetland. Sometimes, like in rocky shores, like in Alaska, you just have to pressure wash it off the rocks. And there's all this marine life living on the rocks is a problem. And then sometimes they just scoop it up with a shovel. I mean, you got to get rid of it. I mean, it's not going to go away on its own. So it's a mess. Let's talk about one in particular that really sort of brought this home to people. And that was the wreck of the Exxon Valdez. It's a ship that was in Alaska, Prince William Sound. Turns out that the captain, this guy named Hazelwood, was drunk, and it was in the morning. And he ran aground, and it was the largest oil spill in U.S. history up until one that happened in 2010. I'll talk about that one in a minute. But basically, so we're talking 10 million plus gallons of oil released into this harbor, and it just killed thousands of sea mammals, hundreds of thousands of birds. I mean, it was all over the news for weeks. I cut up my Exxon card and mailed it to the company. I was so mad. 1,000 miles of coastline just absolutely hammered with oil. Think about that. Thousands of miles, 2,000 kilometers of shoreline that they had to go and scoop up oil and sandblast. The salmon fishery was wiped out for years. The shell fishery I don't think they can eat them even now. Tourism, people used to go there because it was so beautiful. They quit going, so it's like everybody in the area lost money, lost their whole livelihoods. And 10 years later, half the beaches still had visible oil on them. Okay, so it's definitely both an economic as well as an environmental catastrophe. Now, in 2010, there was one that happened. It was called the Deepwater Horizon. They made a movie about this, I think. But basically, what happened was, as oil becomes harder and harder to find, at least like in the United States, they pretty much pumped all the oil they can that was present here. They started to move offshore, right, into this fairly deep water, like thousands of meters down. And so basically, way down deep in the ocean, they built the technology to put this pump station down there. And then up above, there's this floating platform that kind of holds itself in position using GPS with a pipe that comes up. Okay. What happened was, something went wrong and they got a blowout and it just started pumping oil out. And there's supposed to be this mechanism to stop it automatically, but that failed. And so you just had this hole in the ocean that was just dumping oil out of it, and it just kept coming up for like I almost have to say over a month, and it was like like every day it was pumping out as much as the Exxon Valdez spill. Now the good news was it was pretty far offshore, but still, most of it made its way to the surface, and it just drifted in, and it just hammered this huge swath of the south coast of the United States. And many of these places, have had these shell fisheries that were just destroyed, crab fisheries. It had this enormous economic impact. Another famous oil-related disaster. This one doesn't have to do with water, but it's one they sometimes ask on the test. So I think I just thought I'd cover it. And that's the Kuwaiti oil fire. So um, the first Gulf War happened, I want to say, in like around 1990 or 91. And Saddam Hussein of Iraq invaded the country of Kuwait, which was just had a southern border with him. And the United States and other countries came in and pushed him out. But before they left, they decided we're just going to like burn everything. So they just caught all these oil wells on fire. Hundreds of them, like 700 of them, were on fire. I mean, here's a picture from space. You can just see this black smoke. And so, I mean, look at it. It was just disgusting. These things burned for months, and just all these toxins got into the air. People in the area, servicemen, locals, were exposed to all these petrochemicals. These petrochemicals are definitely carcinogenic, and when you get exposed to these levels of it, there's all kinds of health effects. So it was a pretty horrible catastrophe. All right, enough about oil for right now. Let's just move on to talk about other things. So another thing that we're pretty worried about, and this also comes from both petroleum and coal in part, and mining, is heavy metals. So metals that are in the sort of middle part of the periodic table, they often have impacts on human systems. And so there's just a few you should really know about. Okay, I just want to just talk about these five heavy metals. Okay, so there's mercury is a big one. So where does mercury come from? Well, you get it from mining, but a big source is burning coal. So mercury is something that bioaccumulates, and it comes out. It's just put in the air in small amounts from burning coal, but it doesn't go away. Now it causes one of the things: neurologic disorders, developmental disorders, which is super tragic, kidney damage. We're going to look at one of these cases in particular in just a minute. Lead, obviously, we all know that lead is terrible. There's no level of lead exposure that's okay. Where does it come from? From smelting, which means like taking ore rock and getting the metals out of it. Batteries, mining, paint, pipes. Again, this causes neurologic disorders, developmental disorders, miscarriage. Chromium, especially what's called hexavalent chromium, like so the one that is a +6 ion, really bad. This comes from leather tanning and manufacturing of pigments. It's definitely a terrible carcinogen. Cadmium is another metal from welding and again from smelting ores, known to cause kidney damage, bone disease, and then arsenic. This which is also present in some pesticides, but a lot of cases it's like other things, it's from mining and smelting ores. It causes a lot of problems as well. So you should know these. You should know mercury, lead, chromium, cadmium, arsenic. Okay, now one of the problems with heavy metals and other toxins is they tend to bioaccumulate and biomagnify because they don't go away, right? This metal is, things with short half-lives go away, they don't accumulate. but metals don't go away, so they do bioaccumulate. So just if you've forgotten, because we did this earlier in the year, bioaccumulation means over time there's more and more of it in your body because it doesn't leave your body. Biomagnification means as I go from one trophic level to the next, each consumer basically consumes all the toxins accumulated in the organism below them in the food web, and therefore the levels in their bodies go up significantly. So that when you go from one trophic level to the next, the amount of toxins can go up by a factor of 100, 1,000, a million. It can go up tremendously. So let's just talk briefly about a couple, at least one particularly tragic, a couple of these. Okay, one is Minamoto disease, and they will probably ask you about this on the test. They've definitely asked about it in the past. So basically, here's what happened: from the 1930s to the 1960s, this corporation in Japan, in Minamoto Bay, was just dumping toxic waste into the bay, just out of sight, out of mind. That's the way people did things back then. They didn't give it any thought, right? Well, here's a problem with mercury in particular. So mercury, when it is exposed to bacteria, the bacteria bring it in, and they end up converting it from mercury, which is not that absorbable, to a compound called methyl mercury. Basically, you're sticking a carbon and some hydrogens onto it, and that's very easily absorbed, and it bioaccumulates. And so what happens is the people in Japan, in this area, they would harvest shellfish, they would catch fish, and so the bioaccumulation in these fish and the biomagnification in the shellfish and the bioaccumulation in the biomagnification in the higher order consumer fish ended up putting a lot of this methyl mercury into the people there, and they just started presenting these horrible symptoms, like palsies or birth defects, developmental disabilities. It was so horrible, and people are like, "Whoa, I see what's going on. It's this accumulation of mercury in people." And so, the corporation obviously stopped doing that, and the government tried to take care of these people, but it was just a horrible tragedy caused by the accumulation of heavy metals. Talk a bit about toxic waste storage. So leftover chemicals, like after a company does whatever it does, there's often leftover stuff. So what do you do with this? You got this leftover toluene. What do you do with it? Well, a lot of times it just gets stored. At least what they used to do is they just put it in barrels and they bury the barrels underground. Again, the mental state of most people is just out of sight, out of mind. Okay, if I don't see it, I don't worry about it. All right. Well, you need to. So what happened was, for decades, this is what people would do. They would just put it in barrels, put it underground, put dirt on top of it. Well, guess what? Water infiltrates the ground. It causes the metal to corrode, and then the stuff is getting out into the environment when these containers begin to leak. Now it's getting into the groundwater. Once it gets in the groundwater, oh my God, people are drinking it. It vaporizes the air. People are breathing it in, and it can lead to just really horrible health problems. Let's take a look at a particularly tragic one. Well, first of all, let's just look at this. Okay, so here's we bury these things. Let's just look at what can happen. One is you can come in direct contact with them. Okay, so if you come in direct contact with these chemicals, are you going to have a problem? Sometimes what happens is they volatilize, and then they get transported to the air, and people end up breathing them in. Okay, so that's one way we get affected by toxic waste. More often than not, though, what happens is it leaches into the groundwater. And this is when it's really a problem, because what happens when it gets to groundwater, it will sometimes recharge streams. So now what was here is now in a stream. Now it gets into fish, and then it gets into people eat the fish, and the animals eat the fish. A lot of times what happens is, though, people have wells and they'll pump the water up. And when they pump the water up, now they're using it for cooking, they're using it for bathing, they're drinking in it, they're whatever. It's volatilizing in their house, and so it's really mobile stuff. A lot of this toxic waste, especially organic compounds, but heavy metals as well. Now, these compounds here, we'll talk about them some more later on, but the ones you should really be aware of are dioxins, which is like PCB is one you'll hear a lot about, polychlorinated biphenyls, benzenes, which is just like a carbon ring, formaldehyde we've talked about before, toluene, which is also a ring, and methyl chloride. And these toxic wastes are very common, and they have a tendency to bioaccumulate, and so they are of particular concern. Now let's just talk about one example that you can expect to have asked about. This is one that led to changes in U.S. law, which is one reason you might hear about it. So there was a place in New York State near Buffalo where the Niagara Falls is called Love Canal. And basically, it was a toxic waste site. Basically, started building a canal and decided, this canal is not going to work. We're not really going to be able to connect these two rivers. So we had this hole in the ground, and this one company said, man, I could sure use that to dump my toxic waste in. So they just put in tons and tons of toxic waste back in the 50s. Hooker Chemical Company is called. And then they sold it. All right, we're done. Here, it's yours. You can have it. City, you can have it. Love, you can have it for $1. Right? We don't want it. So the city's like, this is great. We got this land for $1. What are we going to do with it? I know. Let's build low-cost housing for poor people. Let's put in some public schools here. Right? It looks good. Right? But unfortunately, underneath it, you had all these barrels of toxic waste. In the 1970s, they got these heavy rains, and basically this fill dirt kind of was soft enough. These things started lifting themselves up towards the surface and leaking. And then these toxins that we talked about on that page, they got out into the surface. There's like literally puddles on the surface of it. People could smell it. People were getting blisters. People were having miscarriages, children with birth defects, all kinds of cancers, developmental problems. And people, go to the doctors and they're like, man, what's with your blood? You have very low blood counts, really high rates of cancer. And so finally they figured out what was going on. And what happened was, it was such a mistake. I remember when this happened. It was like such a catastrophe. I feel like what do we do? It's like our laws really didn't have a way of dealing with it. So the government had to come in and say, okay, we have to clean this up. And so they started a concept called the Superfund Law. And you need to know this one. What we call it is CERCLA. And it basically means the Comprehensive Environmental Response Compensation and Liability Act. You just have to remember CERCLA. Basically, it created what's called a super fund, a big pile of money for cleaning up toxic waste problems. All right. So that is like the government shouldn't be on the hook for it. So basically, it at first it identified all the toxic waste dumps in the country. All right, like Love Canal, that's kind of okay. Then it said all the people who manufacture and are responsible for the production of toxic waste are going to have to pay money into this Superfund system, and this fund, right? And anytime we identify one of these places, we're going to use that money then to mitigate. So that was really the power of it. It said people who pollute, you need to pay in up front. And then we're going to use that to try to fix the things you guys did in the past. And we're going to give the EPA the authority to hold you responsible for any toxic waste you make in the future, and make sure that you present plans to show that you are not going to accidentally release any more of it. So CERCLA is a really important law. It's what my wife did for a job for a number of years. Then there's RCRA, okay, Resource Conservation Recovery Act. Sometimes it's known as, and you should know this term, the cradle to grave law. Basically what it says is that you have to keep track of these substances from the manufacture of them to the use of them to the storage of them. In other words, cradle to grave. So there has to be a continuous record kept of them. And we have to identify all the substances that we consider to be hazardous and make a list of them. And it gives the Environmental Protection Agency the right to control like which things can and cannot be made, how they can be used, how they can be disposed of. And so this is a very important law for the prevention of problems by giving the Environmental Protection Agency the right to have control over the manufacture, use, transportation, and storage of these chemicals. Okay, I know it's a lot. Sorry about that, guys. Let me see here.